So let's talk about different strategies, how you can merge your changes back to the main branch. So let's say we have a kind of typical situation where we basically have a couple of commits. So we have one commit, two commits, three commits, and maybe at some point, and then so we have a couple of commits, right? And at some point we basically made some new changes along the way, right? So we have these commits going this way. Okay, and then at some point we basically branched out. So what strategies do we have? I want to kind of duplicate this whole thing. Oops, is there a way to duplicate it actually? Oh, yes. So one strategy you could apply is basically that's going to be called merge. How does it work? Well, it works in a really simple way. You basically make a merge commit, which going to consist of all the changes from main as well as as well as changes from feature. It's basically going to be just a new commit that still relies on these two, because commits are not dependent, right? They basically say what's new compared to the previous commit, right? They not contain the whole repository. Single commit without its parent does not contain full state. It's merely a difference. It's just a delta, right? So this now has two parents. If you later decide to delete this branch, these two commits will stay forever because these are direct, parents, basically. So you're gonna say that this is two-way merge because this new commit has two parents. Different strategy you can apply, however, is that you could apply this strategy called squash. Oops. So how does squash work? Well, the way squash works is really quite simple. You basically take these commits and you basically set them aside. You set them aside. You combine their changes effectively into a single commit. So now, oops. So now what you have is still a merge commit, but your feature branch changes are concluded with a single commit. And these commits, of course, then basically, go away, right? They merely being basically combined together. Their changes going to be turned into one big commit, as if it's going to be applied in a single go. So basically, we're going to say that this is a, this color is not good. Why do we not have a color? Okay, here we go. So we're gonna say that this is before state, okay, and we're gonna say that this is regular merge, and this is gonna be squash merge, okay, because we're gonna squash all the commits together. So the other strategies we have is that we also have rebase. Now, what rebase is something quite different. So what rebase would be is simply going to say this. Hey, it's going to take these two commits, basically, set them aside. Then it's going to delete these two commits on a feature branch. Okay. And then it's going to basically take these commits. Oops. Well, maybe I should delete this arrow first. So then it's going to basically take these two commits and effectively reapply them to the tip. Now it's important to understand the thing that this by itself does not actually merge those branches. Now they look merged. And if you look at certain Git tools, they're gonna tell you that they're gonna show it as like one graph. It's not gonna really show like any graph split because it kind of looks like there is only one tip. Really, it kind of looks like there's no really branching. Because there's no new commits on the main branch. But what we do next is we do something that's called fast forward merge, which basically means like, hey, can you absorb these commits into itself? And there are two things that can happen. There's a regular merge, which basically says like, well, yeah, we're gonna basically, there are changes on main, there are changes on feature. Now we're gonna combine them with a merge commit, right? But if there is no new changes on main, the only changes on here, it's simply gonna say, I can take this, main pointer, which normally would be here. So this is like our main or master pointer, right? So it's simply gonna say that. I don't know how can I remove this text. So it's simply gonna say, hey, make it here now, right? And now it's gonna just pretend as if this is just one branch and it's all been main, forever, basically, right? So for demonstration purposes, what basically happens with the fast forward merge is basically just absorbs these changes, right? As if it's not really a different branch. It's gonna just like push them to the side, to straighten up the branch. So it's really just one branchless line. Right. So this would be what we would call rebase and fast forward merge. I can actually write fast forward merge. Maybe we can write it in 2 lines. I think it would look a bit better if I would write it like, oops, center. Oh, oi. My cat was on the keyboard. God damn it. My cat was on the keyboard. I'm so sorry. She pressed something. Yeah, so this is going to be so this is going to be rebase and fast forward merge. Right? So this is how you do it that way. Which is pretty nice way to do it. And then there's also even different way where we can combine squashing and rebasing, and then fast forward merge, of course. So this would be basically a combination of these. This will be a combination of really these two in some sense. Is that we're gonna really remake all the feature branch changes into single commit. We're gonna pretend as if it was always a single commit. And then I'm gonna silently absorb it as if it's not even part of a branch, as if it was in the first place made on a main branch. So how that's gonna look like? Basically, well, let's copy this once again. So how that's gonna look like? It's gonna basically, it's gonna take these commits, put them aside, right? Basically, delete these effectively. Well, maybe I should not delete that arrow. Then it's gonna make new commit. Right? Which is gonna be combination of the changes of these two. So it's gonna be single commit, but it's gonna combine changes of both of them. then these commits gonna be, of course, deleted because this is rebase. This is already rewriting history. This is already a new commit with a new hash that simply happens to combine changes on both of them, right? So it's entirely new commit. And now, what you do now is basically you, again, basically set it aside and then apply it on the tip. So basically, you move your feature branch tip basically to the tip of main. You create new commit on the tip of it, which so that you do like rebase. And then what you do, right, is then you basically gonna once again silently absorb it. Which basically, again, since it's only one straight line, there's no branching, there's no two branches, there is only single way to go forward. It's simply going to straighten it out effectively and say like, okay, so, you know, the tip, like the anchor point where it once thought that was tip of main, now it's going to say, well, tip of main is here, just like feature. So they now are basically one branch, for the lack of the better word. And until you're going to start making new changes to feature, they're not going to split. So this is like now as if it's like really one branch. So this would be called, let me just change the color. And this would be called basically squash, rebase, and fast forward merge. It still technically would be possible to force regular merge to occur, and then it would basically keep that squashed commit, and even if there is no changes on the main, it would still like merge it into new commit, on new merge commit. That would be really silly. You can still do it, but in those cases you really don't, because you deliberately choose this strategy to rebase first to make it on the tip, so then you can simply absorb it. If you plan to merge and make merge commit in the first place and keep those two parents, then you don't really rebase, because it makes no point. So that's that. That is that. And yeah, so these are different strategies what you can do. Now, how you achieve those strategies? Well, to achieve those strategies is really quite simple. In regular merge scenario, you basically do git checkout a feature, then you do git merge main, and it just merges, right? In the scenario of squash merge, let's not pretend, but let's like rather write some pretend commit hash for this one. Let's say commit hash for this one is like FAC 123 or something, right? Well, actually, it should be like at least 8 characters. Actually, not. It's a whole different story. Actually, you don't have to use 8 characters when you specify commit by hash. You only have to specify as many characters as it makes it unambiguous for different commits, because you only have to specify as many, so there's only one commit that matches an entire history. But that's a whole different point. But what you simply do is then you simply say git checkout feature, then you say git rebase interactive, so do like a -i flag, and then you specify the commit 1 2 3 4 5. Then you go through this commit process, and this is and it's gonna present you with these like all those different commits you do, and you basically have like commit 1, commit 2, and etc. And it's gonna have this pick option on them. Oops. So basically, what you're gonna do in this case, in that file, we're simply gonna replace every single commit except for the first one. You're gonna replace pick with squash. And like, there's going to be maybe many commits, and there's going to be like, pick commit 3. And it's not, I'm saying commit 3, but it's really going to be like commit message and commit hash. And you're going to change every single one of them to squash. But keep first one as pick. So basically what it's going to do, it's basically going to say, okay, I'm going to apply this first commit. So I'm going to pick it. I'm going to make it survive. And and all the other ones, I'm going to basically squash them. I'm going to like squeeze them together. I'm going to like mush them inside of the first one. Now we could really pick any commit. You don't have to pick the first one. You could pick like third one and squash all the other ones. But it doesn't matter regardless, because in both cases, it's going to incorporate all changes into a single commit, which will have its own hash, which is completely out of your control, because that hash is going to be based on the changes, on timestamp, and a bunch of other things, not on which commit you choose to pick. So just pick a first one and just squash all the other ones. Doesn't really matter. Don't even think about it. Once you do that, that interactive file, you're gonna save and close, and then it's gonna basically open another file. We're gonna write commit message for the thing, and I sort of glossed over this, but you're also gonna specify commit message when you do regular merge. It actually asks you to, but I'm gonna basically gloss over it. You're gonna save it, and it's gonna be basically squashed. And then finally, you're gonna still do regular merge to main, just like in first case. Now, when you do rebase and fast forward merge, well, that's gonna look like this. You're gonna do git checkout feature. Then, this basically all of this, of course, assumes that you already have latest changes to main. I think I really should say that really applies to all of them, right? So like, always make sure you have all latest changes in main. Very important. Do git pull while on main. Very important. Because when you do rebase, and it really applies in both of these last cases, when you do rebase, you make new commits, and if there is feature commits on another branch, you're gonna have all sorts of issues. Really, just make sure you always pull from the main branch, if that's your public branch. And if feature branch is also a branch you working together with someone else, make sure you always pull their changes before you make new commits, because otherwise you're gonna again get a whole bunch of nasty conflicts and on merges. So what you do here is you get checkout feature, and then would you take a look at that? So simple. Just do git rebase main, and it's simply going to reapply all of these commits to the main branch. Very, very simple. And finally, in the last case, if you do squash and merge, I'm really gonna copy this because it's gonna be very similar. So we're gonna check out feature. You're gonna rebase some specific commit to merge all those changes, and I guess to show this thing. Yeah, I guess it's important to copy this label. I really mean this commit, right? Once again, that would be the commit that would end up being, that's the commit that's like parent to the feature branch, the one in the main that it spawns from. Only difference here gonna be is that the only difference gonna be is that you gonna do you're gonna squash, and then before doing git merge, because remember, we don't want to do regular merge. We're gonna first do git rebase main once again to first push that squashed commit basically replay it on the tip of the main. So then when you do merge, it doesn't do a regular merge, two-way merge, three-way merge, as they call it, but it's gonna do rebase instead and just absorb it. And that's really it, I guess. But I guess last thing maybe I want to mention is that Git merge has a whole bunch of useful options. So if you type git rebase, or not rebase, I'm sorry, git merge dash h, it's going to give you like a list of these options. And there's really interesting options. These ones. And these ones can really help you when you want to make sure you do one merge type or the other. It's especially useful when you want to absolutely be sure that you rebased, that's not causing regular merge to happen, right? Regular three-way merge, two-way merge, like with the two parents. You can use this flag, ff only, which is basically what it's going to do. If you're going to do git merge ff only, and then you do like main, for example, it's gonna try to do fast forward merge as if you rebased, as if like your feature branch is on the tip of the main branch. And if it can do it, it will do so. If it cannot do it, and there are diverging, branches, diverging changes, it's simply gonna fail, right? If you don't specify this flag, it's gonna typically by default git configuration, and don't quote me on that. If you changed your default configuration, it might be different, but typically how the way it's set, it's gonna attempt to do fast forward first by default without any flags. If it can't, it will make regular merge. If you specify this flag, if it cannot do fast forward, it will write out fail. So if you really want to do fast forward, this will prevent you from doing possibly regular merge, and it's really nice because if that's what you want to do, it's going to be like the safeguard saying no. And also, similarly, there is opposite flag where you can specify. So there's also FF. You can do like dash FF, like this. That simply is like a hint. This you typically don't need, as I say. It will, if it can do it, it will do it automatically. But if you change the configuration or set it, well, like if you change it later, or if you change it during the installation, from the default, you can set it to do always regular merge, and this can simply say, well, do fast forward if you can. So if the configuration is set to always try, if it can't do fast forward, it will do it regardless. If you set it to always do regular merge, even if it can fast forward, this will basically be like a hint saying like, if you can do fast forward. I'm saying a hint, but it's really, it's like it will always do it if it can. It's not like the Git has its own mind. It's gonna basically check like, is it on the tip? It's on the tip. Fast forward. Similarly, there is also no FF. I think it's spelled like this. Yeah. Which, as you might realize, regardless really of your settings, even if you have it set to always do regular merge by default, or if you have it set to that like automatic mode, or even if you set it to do only fast forward, because you can also set it in git config, so it always by default without any flags only ever try to fast forward, which maybe I can show in the other video, all these settings, is that basically this overrides it for this specific one, instance. It's going to basically say like, I don't care if you're on tip of the branch, always do regular merge with two parents, no fast forward, I don't care. Which is, again, really good if you're specifically seeking for that strategy. Maybe there are reasons for that. I don't typically see this being used often, but you probably can find use for it. It's probably not really any harm that exists. Most certainly someone is using it somewhere. So that's really it. That's really it for this video, and thanks so much for watching.